Welcome to day 13. For your homework, you'll be finishing up the 2017 free response, and the gold packet, you'll be finishing up those multiple choice, which will be calculator questions. Like we've done on the other Wednesdays, pause the video right now, check your multiple choice ones, then skip ahead and only listen to the explanations for the multiple choice ones you either got wrong, or maybe if you guessed on it and you didn't really know how to do it, you could look at those ones as well, and then watch through the entire free response explanations. So go ahead, you can pause now, and then skip ahead to the explanations. So for 15, at 6, we want to recognize that f prime is 0. We want to notice that the slope is positive, so f double prime is a positive number. And notice it's going to also be a relative min in f because f prime is switching from negative to positive. So because of that, we know we'll have a negative number because our accumulation from 0 on to 6 will be negatives. So if you have a negative for h of 6, that should be the smallest. At h prime, since we had the relative min, we should have a 0 for the slope of the or for the value of the derivative, and then the second derivative should be positive because we have a slope that's positive in this one. So choice A is the one that mimicked that. In 16, sub in your 1, 3 to the differential equation, you get -2. If they're equal steps, they have to each be a half, so multiply that by the half, and you get -1. The -1 gets applied to that current y value, which now gives us 2. Sub in the 1.5 and 2 to your differential equation, you get -0.5. Multiply that by your step of 0.5 to get -0.25. Apply that to the previous y value, and we get 1.75, but they just have that written as 7/4. So we want to recognize the factorials in the denominator are all odds. That wants us to think of sign. But notice the exponents are 1 less than those factorials, so we would have had 1x divided out, so that's sine x over x, so choice C. In 18, we're starting from an x value of 2, and we want to go to -5. Your y value at 2 was 1, so we have 1 plus the integral from 2 to -5. We've got to have the small one on the bottom, so we switch the integral values but negate out front. So we're going to have 1 minus whatever the area was from -5 to 2. So you have a triangle with an area of 3, and then you have the semicircle with an area of 2 pi, which is under, so it's minus. Distribute your negative, and you end up getting choice A. In 19, we want to take the derivative because they're saying the slope is 1/2. So do a quotient rule and neaten it up. We'll set it equal to 1/2. And then a couple different ways you could solve. I divided the 2 over to get a 4th, and then took the square root of both sides, so had plus and minus 1/2 equals the 1 over x plus 2. Well, that means that the x plus 2 is either equal to 2 or -2. Solve for x, you get then x is 0 or -4, and sub back into the original equation to find the y's that go with those. So we would have 0, 0, and -4, 2, so that ends up as choice C. In 20, we got to do our partial fractions. I skipped the first step where you have it factored out. We would have had a over x plus 2 and b over x plus 1. And then when you multiply, you have a and b multiplied by the opposite thing. Let x equal your strategic values. Sub in and then solve for either a or b. We end up getting b is 3 and a is 2. Put those in front of your integrals, and our antiderivative would be a natural log with an absolute value. Because each of the coefficients of x were 1, we didn't have any correction out front. Sub in your 1s and your 0s. And then we have to bring it all together using log laws. We're subtracting, so divide the inside of the logs, and that eventually leads to natural log of 18. Horizontal asymptote of y equals 5. We want to think ratio leading coefficients. So in choice E, the ratio of those leading coefficients is 20 divided by 4, so we get 5. In our power series that was given to us in 22, our center was 3. If we're converging at 5, that means our radius is at least 2. So going the other direction, we're going to 1, maybe including the 1, maybe not. But then of our choices, 2 is definitely a spot where it converges, so choice D. In 23, if it's linear, our derivative should be a constant, so that's choice A. In 24, this was a tricky question. This is showing integration by parts. So in the original, our two options are, we could have had u equaling f of x and dv equaling sine x dx, or the u might have equaled sine x and the dv would have equaled f of x dx. Well, notice based on the right side there, and just a reminder, we have uv minus the integral of v du. So based on the inside of the integral there, we've got a 4x cubed and we've got a cos x, and one of them's got to be a minus because the plus in front of the integral. One will be the v and one will be the du. So let's look at our options. So in this first one, du would equal f prime of x dx. Capital V would equal negative cos x. Over here, the du would equal cos x dx, and our v would equal whatever the antiderivative of f is. So let's say that that minus went with the cos. If that minus went with the cos, then that would mean we would have this scenario here, where the v du is the minus cos x times f prime of x. So the minus came out front. So this part's our v, and then that would be the du. So if that was the du, then that means the 4x cubed must be the derivative of what we were working with for the 4x cubed. Or the 4x cubed should be the derivative of what the u was equal to. So if we look at our choices, the only one whose derivative would be 4x cubed is the x to the fourth one there. So we have choice E. In 25, because we have an infinity on our integral, we have an improper integral, we've got to do limit as b approaches infinity. Do a u substitution. So we got u equals negative x squared. You'll end up having a correction by a negative a half. Redefine your bounds of your integral. Antiderivative e to the u is e to the u. Fill in as b goes to infinity. This is going to end up as e to the negative infinity. So as e goes to negative infinity far left, that's going to 0. So we end up with a minus 1/2 times a negative e to the negative 1. And rearranging that a little bit, it ends up being 1 over 2e, which is choice B. In 26, we need to remember that x is r cos theta and y is r sine theta. Our derivative, we would have to do the product rule for dy d theta on top and the product rule for dx d theta on the bottom. Since that's kind of messy, I just wrote them separately. So I wrote my x, I had r cos theta. I did my product rule for dx d theta, and then subbed in the 0 for theta to get 2. So that's going to end up going in the denominator because it's dy over dx. Then I did my y equals r sine theta. did the product rule, filled in 0, got 1, so my dy over dx was just 1 over 2, or 1/2. For 27, in the first one, we need the exponent in the denominator there to be greater than 1. So if 2p is greater than 1, p has to be greater than 1/2. In the second one, we need the absolute value of that inside there to be less than 1. So we need p to be greater than -1 but less than 1. Or sorry, p over 2 to be greater than -1 but less than 1. So we multiply by 2, and p's got to be bigger than -2 and less than 2. The intersection of those two inequalities ends up being choice C, greater than 1/2 but less than 2. In 28, if you do an integral from 1 to 1, that's just 0. G of 1, they told us was 6. 6 minus 6 is 0. Take the derivative of the top and bottom. On top, you're doing your second fundamental theorem of calculus. So the x goes in for t. And technically, we have a times 1 after, because that's the derivative of the x. On bottom, we just have g prime. Fill in your 1's, and those are the values they gave us. 6 over 3, which is just 2. Moving over to the free response. This is basically the same picture we saw on one of the multiple choice ones. So if we want to find f of -6, that's really the integral from -2 to -6, and that's what's shown over here. So flip that, and that's really the, I miswrote this. This should be a -6 here. That should be a -2. So that's really minus the integral from -6 to -2. So from -6 to -2, that's just a triangle, and the area is just 3. So in 3, so we have f of -6. So they told us f of -2 was 7. So we're working backwards. So when you work backwards, all of these signs are changed. So even though that is an area of 4 above the x-axis, when we go backwards, it gets negated. So we end up doing 7 minus the 4 to give us 3. For the 5, we're going forwards. So to the 7, you're just subtracting the half a circle, which had a area of 2 pi, and then adding on that triangle, which had a radius of, or which had a base of 3 and a height of 2, so an area of 3. So combine those, and we get the 10 minus 2 pi. In B, we're increasing when f prime is positive. So close bracket at -6 to -2, and then again from 2 to 5. And the reasoning is because f prime is greater than 0. The absolute min, we need to check the relative mins and the endpoints. Well, at x equals 2, we know there's a relative min or a local min, however you want to say it, because f prime switches from negative to positive. Well, f of -6 we already found in part A was 3. F of 5 we already found in part A was 10 minus 2 pi, which is roughly 3.72. And then f of 2 is just finding the area from -2 to 2. At -2 we were already at 7, and subtract off the half circle, which was 2 pi. So that's 0.72. That's going to be the smallest one. They wanted the absolute min, not the value of x, so our absolute min is 7 minus 2 pi. And our second derivative in 3D, you're just taking the slope of f prime. So at -5, the slope is just -1/2. At 3, we have a corner point, though. So we would say that f double prime 3 doesn't exist. You can either say because there's a corner. You could say your slope from the left is not equal to the slope from the right, because there has to be a gradual change in slope for the derivative to exist. And moving over to 4, they told us our initial point was 0, 91. So sub the 91 in for h, and that'll give us that our dh over dt at t equals 0 is -16. So then we'll do our equation of the tangent line. H minus 91 equals -16. Then we really have t minus 0, but the 0 you don't need to worry about. We sub in 3 because we wanted to know at t equals 3, and we get 48 degrees. Make sure you put Celsius on there. For our second derivative, it's just -4, but then we got to multiply by a dH over dt. So replace dH over dt with what it was they told us. Then we're going to fill in 91 because we want to do the initial. We get, and the reason we want the initial is that's where our point of tangency was for the tangent line in the curve. We eventually get 4 degrees Celsius per minute squared. Because that second derivative is positive, that means the function is concave up there. So I have a little picture there of a concave up with the tangent line underneath. So that means our tangent line estimates will always be underestimates since the function was concave up. And then in 4c, they're giving us dg over dt. To solve it, we've got to solve the differential equation. So divide, I left the negative over on the right, the -1, and I just divided over the g minus 27 to the 2/3 and multiplied the dt over to the right. And I just wrote that as g minus 27 to the -2/3. We'll take the integral of both sides. Technically, that's a u substitution on the left, but since your coefficient's 1, there's no correction. And I subbed in the 91 and the 0 to resolve the t, or to resolve the c, which was 12. Once we had that, divide by 3, cube both sides, and add the 27. And that gives us our solution to that differential equation. We then wanted to know at t equals 3, what is our internal temperature? So just sub in the 3 to that, and we get 54 degrees Celsius. So you've got the homework problems to work on for the rest of today. Have a great rest of your day.